So math, so this is 3.3. So we're finishing 3.3. We did, like we said, half of it last time. So this is 3.3, the long-awaited conclusion. You couldn't think about anything else all weekend, right? But how chapter 3, I'm sorry, I just always joke around. It's always, every now and then it just strikes me as funny that you're paying me to do this to you, right? All right, enough with the joking around. It is kind of funny, though. All right, I hope you're having some fun. Math class contains 5 females, 3 of whom speak French, and the rest speak only English. And 8 males, 2 of whom speak French, and the rest speak only English. A student in the class is chosen at random. You're told it's a female, probability they speak French. All right. Any idea at all? Like, suppose you see this, 2 weeks, week after next on the exam. What in the world are you supposed to do on this question? Yeah, the chart. The chart, right? Remember the tables? This is another one of those make the table thing. So can you do it? So let's go back to the words one more time. So what you're looking for is the 2 characteristics that you can have or not have. What are the 2 characteristics they're talking about on this one? Yeah, you can speak French or English. That's language. We'll call that language. So there's a language characteristic. You either speak French or English. And then there's your gender. You're male or female. So it's talking about those 2 things. So in every one of these problems, and we'll do a bunch more tonight. So like I said, I want you to be a pro. I'm going to try to help you become really comfortable with these by the end of the night. You're looking for 2 characteristics. You're going to put one of them on the side, one of them on the top. It doesn't really matter which one goes where. You can do it either way. But gender, one place, and language, the other, or vice versa. It doesn't matter. So I'll make a big box here. This is number 9. So number 9. So I'm going to make a big box, and I'm going to put, gender at the top. Put it on the side, doesn't matter. Male, female. And then on the side, language. Or you could have put the gender on the side and the language on the top. It doesn't matter at all. Language, French or English. It doesn't matter what order you put. English first, then French. Female first, then male. Whatever. Does not matter. Is that good? And then you just start putting in the percentages. So let's go back. What does it say? A math class contains 5 females. Or there's no percentages. There's the numbers, huh? In this one. Math class contains 5 females, 3 of whom speak French. 5 females, 3 of whom speak French. So where am I going to put that? 5 females. Where did I put the 5 first off? 5 females. Yeah, it's down here. It's the total, isn't it? It's the total for females. 3 of whom speak French. Where's that go? In the French female box, huh? Is that making sense? And then we'll go back. Let's see. And the rest speak only English. So the rest, what's the rest? The other 2, huh? So far so good? See what they're saying there? Okay. The next fact, they say 8 males. So I'll go back. Where do I put the 8 males? Yeah, the bottom, the total number of males, huh? 8 males, 2 of whom speak French, and the rest only English. So 2 speak French, the rest, 6, only English. Is that good? So once we have the box, we can answer all their little questions. Everybody see how we got that? And now come their questions. A student in the class is chosen at random. If you're told the student is a female, what's the probability that the student can speak French? If you're told the student is a female, what's the probability that she can speak French? So, you're told it's a female. What's the probability that they speak French? So they grab somebody at random and they say, hey, it is a female. What's the chance the person speaks French? So, do you see that this is a given question again? We've been talking about given a little bit, right? So what's given on this problem? The female. That's the given. That's what we know for sure. That's what we know for sure. Remember how the given stuff works, right? It affects the denominator, doesn't it? Remember us talking about that? It limits the possibilities. It's got to be a female. So the denominator is always what's given because that's all the possibilities. So how many different people, if they're saying it's a female, how many total people could it even be? How many total people are possible?
5.
Yeah, the total number of females, 5. It's got to be one of those 5 females, doesn't it? Is that making good sense? Okay, and then on the top goes French, What's the probability they speak French? The probability thing always goes on the top. So how many speak French out of those 5? 3 out of 5 speak French. Divide that into your kid. Do they want decimal or fraction? What do they want here? Do they? When you click on the thing, they want a fraction, So I'll just leave it like that. 3 out of 5. Just like that. We good? That making sense? The given is always the denominator. Given is always the denominator. All right, let's try part B. Part B says the first student is placed back into the class and another student is chosen at random. So they're picking another person. If you're told the student can speak French, what's the chance it's a female? Wait a minute, isn't that what we just answered? What is it? Yeah, they're reversing it. Do you see that? So they're saying, in other words, let me write it down here. They're saying, you're told the person speaks French. What's the probability that it's a female? In other words, they grabbed somebody at random out of the class, and they said, hey, by the way, I got a French speaker. What's the chance it's a female? See how that's a little different? That's exactly the opposite from part A. When they said, I grabbed somebody at random, it's a female. What's the chance she also speaks French? That was what we just did in part A. See how they've reversed it? They've reversed it. So what's given this time? The French speaking. That's the given. The given is the French speaking. And so what's the probability of that? So can you finish that one up? What's that going to be? French? No, not French. Female, Female over given. So it's which group? It's these 5, isn't it? We're talking about those 5 people. Coincidentally, it comes out the same as the other denominator. And we're talking about these 5 people up here because we know it's a French speaker. We're told that they speak French. So it's one of those 5 people. And what's the chance it's a female? It's the same answer. That's funny. It coincidentally came out the same. But it won't always. I made this big deal that it's different and it came out the same. But that was a big coincidence. Make sense on that? How that works? So whatever's given is our denominator. And whatever the probability is, that's the numerator. All right, the hard part's probably making the box, right? We'll do more of that. All right, let's try number 10. Home pregnancy test was given to women. Then pregnancy was verified through blood tests. All right, so you want to put that chart down on your paper there, and then we'll see if we can answer the questions. Let's make sure we're understanding what the chart says first off. What's that 52 there? Tell me about those 52 people. The pregnant and the test told them they're pregnant, right? It came out positive, right? They're pregnant and the test said so. Tell me about these 4 people here. Yeah, they're not pregnant, but the test said they are. Right? Again, no medical tests are perfect. They're always going by hormone levels and different things, which body's complex. So we see mistakes. All medical tests have room for error. They try to balance those errors statistically. And right, so you understand the rest of the chart, right? So see if you can answer their first question. Give you a second. What's this little straight line thing here? Given, right? Remember that's a shorthand symbol for given. So they're basically saying, what's the probability of a positive test result given that the woman is pregnant? So what's given is what you know, like what you know for sure, right? We know for sure the woman is pregnant. What's the probability the test will come back positive? All right, so the denominator is always what's given, right? That determines the possibilities, right? You remember that? Maybe this person is pregnant. So what does that mean then? How many people up there are pregnant? That limits the field. We're not talking about all 126 people now, right? Because all 126 weren't really pregnant. We're just talking about the pregnant people. How many people up there are pregnant?
61.
61. That's the pregnant total, isn't it? It's one of those 61 people. It limits the field, doesn't it? Limits the possibilities. And then among those, how many tested positive? 52. 52 out of 61. I guess they want a decimal to 4 places. 52 out of 61. What's that? Can you say that for me one more time? I'm just giving you a hard time. Does it? Okay. I was just kidding you because you had something in your mouth. I thought it was entertaining. All right. 8, 5, 2, 5. I think it rounds to 5. They'll take a fraction too, huh? Okay. Either way, thanks. Yeah, and you guys remember how to reduce fractions, right? Hit math, enter if you need to on that. Good. All right, how about part B? What is the probability that the woman is pregnant, given that the test is positive? Try that one. Maybe you already have while I was going on and on. Give you. All right, so what is the probability that the woman is pregnant, given that the test is positive? So now they're limiting the field. We're not talking about all, 126 people. We're just talking about those who tested positive. A little different than part A. This last time part A was talking about people women who were pregnant. Part B, we're talking about people that tested positive. They may or may not be pregnant, but they tested positive, right? That's what's given. That's what we know for sure. That's what we're limiting ourselves to, is people that tested positive. We're given. We grab somebody at random, and they're saying, hey, this person I grabbed at random, they did test positive, like me saying, I did get a number higher than 4. They did test positive. So what does that limit the field to? How many people tested positive? 56. It's the 52 and the 4. Those people all tested positive. So that's our denominator. Bring it down here. That's our denominator, right? The given is always the denom, huh? That's the 56. And out of those, how many were pregnant? 52, the great majority. So if you reduce it to a fraction on your calculator, I think it'll be, 26 out of 25 over 28. I think it'll reduce again. 13 out of 14. So 13 out of 14, or you could do a decimal, I guess. It'll go either way. 13 out of 14 or whatever that decimal is. That make sense on that? Getting the hang of this? How about, and then C would be easy. Let's jump down to D. How about we do D? Probability not pregnant given negative. There, so you good? Probability not pregnant. I'm jumping down to D. Probability not pregnant. This is the given line thing here. Given negative. It's almost like a fraction. It kind of looks like a fraction. You could treat it that way. That'll work nice. That's really what we're doing, right? Not pregnant over negative. It is. It's like a sideways fraction. Just make it a vertical fraction. You're right on track. So we're talking about the people then that tested negative. We're given, the given is the denom, huh? We're given that they tested negative. How many people tested negative? Yeah, 70 people total. The 9 and the 61 all tested negative, didn't they? 70. And what's the, how many of those were not pregnant? 61 out of 70. So you can leave it that way, or you can get a decimal. I guess it takes either one on this problem. Now, fraction won't reduce. Nothing goes into 61 and 70. Or you can make it a decimal. Is that good? Getting the hang of the given? Yeah.
I'm confused how to read that.
The line?
No, the chart.
Oh, the chart? On that? Yeah, we can go through the parts on that. So these 52, right here, they were pregnant and tested positive. So these 9... they were pregnant, but the test said they weren't. They tested negative. Does that all make sense? I'm sure she's not alone. Is this making sense on the chart? Please ask questions if you're not sure as I'm going here. How about the 4? What are they? They're not pregnant and tested positive. So it gave them a false positive, didn't it? It said they're pregnant, positive test result, but they're not really. And then here, these 61, they got a negative test result, and they're not pregnant, so that was correct. And the rest are totals. The bottom and the right side, those are all just totals of the different pieces. Does that make sense? Any other questions on this problem? Is the given thing getting a little easier? Right here. Here it is in the homework for us. This is number 11. It says a company estimates that 0.1% of their products will fail after the original warranty period, but within 2 years of the purchase, with a replacement cost of $500. What are they talking about? They're saying, well, let's keep going and I'll put it all together. If they offer a 2-year extended warranty for $76, what is the company's expected value of each warranty sold? So we're going to get into the science, the math, of how companies do warranties or insurance or gambling. They're all the same thing. Insurance companies are gambling. So are warranties, right? All this is a form of gambling, is what it is, right? In other words, because if you buy the $76 warranty and the thing doesn't break in the 2 years, then you wasted your money in the end, right? Some people would say, well, you had peace of mind, and then sure, that's true. But still, in the end, the money was for nothing. But if it breaks during those 2 years, then they replace a $500 part for you with no charge. You really made money, didn't you? Then it was a wise investment. So, well, how does a company, how do they know what to charge for a warranty? Because they want, companies are in the business to make money. Of course, so we all know that. So how does the company set a warranty price to make sure they're going to make money in the long run? Well, they do exactly what the gambling industry does. They calculate the expected value. So that's what we're going to do. This question is expected value. Expected value means average value. It's called that sometimes also. Let me write it that way. So average or expected value. That's what you have to figure out. If you're doing something random, like gambling, insurance, warranties, they're all random. You don't know if the thing's going to break or not during the year. You don't know if you're going to crash your car and need that insurance or not. It's all random. Yet there is an average. There is an average. So let's figure out how you do it. How do you do it? You got to first off figure out the net dollars. And then next to it, the probability for each of those events. So you just think about every different thing that could happen, the probability of it, and the net dollars. So what's the first thing can happen? The item breaks during the year. The item that the company warranties could break during the 2-year period. So if it breaks during the 2-year period, and we're taking the company's perspective, right? It says company's expected value. So from their bottom line perspective, what happens to the company's bank account? Bottom line, net, everything considered, if the product breaks during the year. What do they gain or lose? Is it just that? But they gained the 76. Right? So they gained the 76, but they lose the 500, which is net result minus 424, I think. You with me? So if the product breaks during the year, or the 2 years, they lose $424 on the deal, don't they? That's the net result to their bottom line, which is what they care about. Right? In the end, because they got the $76 from you and the warranty, but they had to pay out $500 to fix your thing if it breaks during those 2 years. So net effect, they lost $424. What's the probability of that thing breaking during those 2 years? Right there, 0.1%. That's 0.001, right? Because it was 0.1%, which means move back 2 places, so 0.001 is the decimal version. Good so far? Now there's another possibility. The thing does not break during the 2 years. So if the thing does not break during the 2 years, then what's the bottom line effect to the company's bottom line? They just gain your $76. Never have to pay out anything. Plus $76. What's the chance of that? What's the chance it will not break during the year? So if there's a 10% chance of rain tomorrow, what's the chance it will not rain? If there's a 1% chance of rain tomorrow, what's the chance it will not rain? 99. If there's a 0.1 chance of rain tomorrow, what's the chance it won't? 1 minus that, huh? So in this case, it's 0.001. So if there's a 0.001, right, the probability it's going to break, right here, then 1 minus that, 0.999, is the probability that it will not break during the 2-year period. 0.999. Very likely to not break during the 2-year period. So they'd have to look at a history of their product and how often it breaks in the 2-year period. So, okay, so there's everything, right? The product either breaks or doesn't break. If it breaks, they lose $424. There's a 0.001 chance it's going to break during the 2 years. If it does not break, they gain $76. And there's a 0.999 chance it will not break during the 2-year warranty period. So what do we do now? Now we hit the buttons on our calculator. Well, here, I'll leave this down here. Now, here, I'll just leave this there. So, whoops, kind of messed everything up there. There we go. Now you just put it in L1 and L2. So this is L1, and this side is L2. I'll write it over here. So L1, put in minus 424 and plus 76. L2, put in 0.001 and 0.999. So put that in L1 and L2 in your TI 8384 calculator. And then when you're all done, in fact, I'm going to go to a fresh screen here. I'm out of room. What number is this? Number 11? So L1 again, minus 424 and plus 76. And L2, 0.001 and 0.999. And then, so after you put those in, hit stat 1 var, and you've got to put in L1, L2, or if you have the newer kind that says, what does it say, list and frequency list? If it says list, remember we did this before? You've got to put in L1, and whenever you have 2 lists, you've got to put in L1 and L2 when you get an answer, and then find X bar, because that's the average. We're looking for average value or expected value. To get the L1 to pop on your screen, you got to hit second and 1, and to get the L2, you've got to hit second and 2, and make sure you put that comma between them. That comma is not optional. It's absolutely necessary. Little commas above the 7. Put that comma between them. X bar 75.5. What does that number mean? Yep, that's the average the company makes per warranty, right? They don't make $75 on any one warranty, right? They sell them for $76, but they break so seldom that the average comes out $75.50 per warranty sold. That's money in the bank to them. Do you see why they sell warranties? See how that works? I looked it up in my office a couple hours ago. You've got to put the money in L1. It really does matter. I swapped them and it gave me a big error. Yeah, good question. You've got to put the money in L1. It won't work the other way. And the probabilities in L2. I forgot it a couple hours ago and spent 15 minutes being mad at the calculator and then realized it was my problem. So is that...
The top is just the replacement cost and the bottom is the warranty price?
So I got the top by a gain of 70. If it breaks, they're going to gain 76 but lose 500. Right? They're going to take in 76 but pay out 500. That's how the minus 424 came about. It's what's going to happen if it breaks to their bank account. And the bottom is if it does not break, they just gain the warranty price.
That makes more sense.
All right, let's try another one. Let's try number 12 here. Okay, so how about number 12? Based on historical data, an insurance company estimates that a particular customer has a 1.3% likelihood of having an accident in the next year, with the average insurance payout being $2,400. And so, $2,400 average insurance payout, chance of having an accident 1.3%. If the company charges this customer an annual premium of $80, who do they charge $80 a year to for car insurance? What's that? That ain't what they're charging me. I've got all these young people on my insurance policy. They're taking me to the cleaners. What is the company's expected value of the insurance policy? So what does the company expect to make every year off the insurance policy? If they're charging, it's just like the warranty, right? Same kind of thing. That's all an insurance policy is, like a warranty. $80 is their charge per year, which is crazy low. There's a 1.3% chance of an accident. And in the case of an accident, they pay out an average of $2,400 per accident. So this is what they calculate. So can you do the same thing? Let's give it a try. Set up the same exact table. What kind of table? Meaning you're going to say accident during the year, no accident. Like with the warranty, the thing breaks, it doesn't break. Doesn't matter what order you put them in. You can go, accident first or vice versa. Doesn't matter at all. And then for each of those cases, what are you going to do? Expected value always is the net dollars to the company's bank account, followed by the probability of that happening. It's always net dollars and then probability. So if somebody has an accident, what's going to happen to the company's bank account that year? Get the net effect. They're taking in the $80 premium, they're paying out for the repair, right? Versus no accident, crank out the probabilities, see if you can get it. So let's think about, if there's an accident during the year, what's going to happen to the company's bank account? What's the net result to their bank account if there is an accident during the year? Yeah, they'll gain the $80 premium. They gain that every year, whatever happens. But they'll pay out $2,400. So that's negative $2,320 is going to be the net result to their bank account if we have an accident during the year. Right? They took $80 from us, but they paid out $2,400. So they lost $2,320. It's the net effect of their bank account, right? If we have an accident during the year. What's the probability that that's going to happen? It says right here 1.3%, which means move the decimal back 2 places, 0.013. is the decimal version of 1.3%. Next, what's the chance, or what's the money, the net dollars, if we have no accident during the year? What's the company bottom line? They're just going to be plus $80. They're just going to gain the $80 premium, and that's all. Never have to pay out. And what's the probability of us not having an accident during the year? 1 minus 0.013, which is 0.987. So now put those in your calculator in L1 and L2. You know what I mean? So you put in L1 is minus 2320 and regular 80, and L2 is 0.013 and 0.987. Put those in L1 and L2. Hit the buttons, hit the stat, calc, L1, L2. 48.8. Positive. Positive 48.8. Sounds like a couple people getting that? Good. So that makes sense. So in other words, what does that number mean? On average, every policy that insurance company sells, they will make $48.80 on, typically. Do you see how they know where to set their pricing? Even though they're paying out $2,400, they're collecting from so many people who don't have accidents that in the end it all balances out. And this is what they know these calculations. They have people called actuaries who are the mathematicians who work that out. Will, did you have a question?
Yeah. Just
does that make sense on the 48.8 there? So they'll make on average $48.80 per policy. So they have a motive to sell a lot of policies. They're making money on the average. So whenever you buy a new or used car, it's always used for me. Whenever you buy a used car, it's for me. At the end, they always ask you, do you want the warranty, right? They always try to sell you the warranty. And they pull out the little thing. They go, if something breaks on this car, it's going to be $1,300. It's going to be da-da-da-da-da-da-da. Know now the math behind what they're doing. They're being honest. I'm not saying they're being dishonest. They're right. You know, if you buy the warranty, it'll cover. But why are they wanting to sell you that? Because they know on average, they're going to make money. It's not a bad thing, but let's just be straight. Let's have knowledge. That's what college is all about, right? To have knowledge. That's exactly what they're doing. It's exactly what goes through my mind. We had to buy a car 6 months ago because I don't want to crash. Anyway, we totaled it. We had to get a new one. And sure enough, as soon as we close the deal, I'm there with my wife, and they whip out that, do you want a warranty? It's for me. It's a quick answer. No, thank you. No, thank you. That's why I buy Toyotas and Hondas. They're not supposed to break, and they don't usually. I've had pretty good luck with them.
So you never buy warranties?
I virtually never buy warranties. Yeah.
Like your phone or appliances?
Yeah, I'm not. I mean, not that you have to. I'm not saying you're dumb if you buy warranties, but on average, they're doing that for a reason. That's why they're selling this, because they know on average they're going to make money. On average, I don't want to give them my money. Now, the truth is, every now and then something happens, and my wife isn't as enthusiastic as I am about that. But I'm always like, they're making money on average on those things. That's what they're doing. We're not playing a game. What's that?
That's what emergency fund.
Right? Yeah, that's always better if you can save up your own. It's true. Yeah. Okay, so life insurance. So a 40-year-old man in the United States has a 0.245% risk of dying during the next year. Do you know they have you down on a table somewhere? They have these what's they're called? They're called mortality tables. It sounds so gruesome. And really, type it into Google right now. Mortality tables. You can see your number, the chance that you will die based on your age and your gender during the year 2019. Well, there's not much left now, but during the next 12 months. They'll give, and that's what the actuaries, those are the mathematicians that work for the insurance companies that do this stuff all the time. That's what they get. So life insurance agents always consult. That's how they set prices. Mortality tables. The chance you will die during the year. It depends on your age and your health and all that, and your gender. So let's say for a 40-year-old man, there's a 0.245% chance of death during the year. So the higher the chance of death, the more they're going to charge for the premium, because they got to make money in the end, right? That's what they're doing. I do have life insurance, by the way. Even though I'm losing money on it, if I die, that would be a problem. So if I die early, I'm going to die, but die early, that would be a problem. So there's time. I don't mean to say insurance is never worth it. I have life insurance, because if I suddenly die, my wife and kids are in a bad spot. So I do have that, even though I'm losing money every year on it, and it sort of bugs me. It would be stupid to not have it. All right, so let's do the numbers. Same kind of thing. There's two things that can happen during the year. What are those two things? You die or you don't die, right? So now, from whose perspective is this? For the person by. So this time, we're not taking the company's perspective. We're taking the perspective of the buyer. Do you realize with expected value, you're either doing the company's bank account or your own bank account? It's the same answer in the end, just switches signs, is all it is. So we're doing the person's bank account. So let's do the person's net dollars and the probability. Okay, so there's two things that can happen. The person dies during the year, or the person lives through the year. So if the person dies during the year, what happens to his or her, or it's a him here, his family's bank account? They collect $100,000, but that's not the whole story. It's most of the story. But they did have to pay that $270 premium. Right? So whatever that is. So you can just type it, by the way, you can just type that in just like that. Yeah, do you guys know that? You don't have to figure out the number. Just literally go into L1, type in 100,000 minus 270. It'll figure it out for you. Just type in 100,000 minus 270. Hit enter in L1 box. It'll figure it out for you. Don't even have to mess with it. Yeah.
How'd you get the 270? Wouldn't it be 270 times 40? Because it's every year that he's...
Oh, no, we're just doing for 1 year.
Oh.
We're just doing for 1 year. A person who's 40 right now, for the next year, that's the insurance policy that covers him for 1 year. Yes, good question. We're just doing this for 1 year. They always do it 1 year at a time. Now, and what's the probability of him dying during the year? 0.245%. That means you got to move decimal back 2 places. 0.00245 from the mortality table. They're public information. Next, what happens to the bank account if the person lives through the year? They 270. They lose $270. They just pay out the premium and get nothing for it. What a waste. No. What's the chance of that? Literally, also, you could just type in 1 minus here too. Everybody, you can just type in 1 minus 0.00245. Hit enter. The calculator will take care of it for you. You can always just do that. 1 minus 0.00245. It's going to be 99755. Calculator will take care of that for you. Put in L1, L2. Hit the buttons. X bar. Has anybody got it? It's going to be negative something. Negative 20. So in other words, you're losing on average every year you buy life insurance, $25.49. So that's from your perspective. That's why it's negative. You're losing. The insurance company is gaining. That's why they're interested in selling you an insurance policy. It's not just out of the kindness of their hearts. They know on average they will make money. Is this good? Let's do one more. I'll move on quickly to the last one. It's a little different. The PTO is selling raffle tickets to raise money for classroom supplies. A raffle ticket costs $3. There's one winning ticket out of 240 tickets sold. The winner gets a prize worth $74. Round your answer there said, what is the expected value to you of one raffle ticket? All gambling, all insurance, all warranties, it's all the same game. So they want us to figure out the average expected value. What are we going to do? Same exact thing. Net dollars, probability. There's two things that can happen in this raffle drawing for us, the buyer of a ticket. Right? Remember, it's to you, right? It's our perspective right there. What are the two things that can happen? Yeah, we win or we lose. So if we win, what happens to our bank account? How much exactly? Yeah, we lose the $3. You can write it either order you want. We win the $74, but we lose $3. So we're really positive $71, aren't we? Our bank account goes up $71. What's the probability of that? What's the probability we're going to win that raffle? You can literally type in 1 divided by 240 and just hit enter. It'll take care of the number for you. Does that make sense? Right? Because there's only one winner out of 240 tickets. One winner out of 240. So just literally the probability you're going to win is 1 out of 240. Just type in 1 divided by 240, hit enter. It'll come up with the number, whatever it is. I don't even know. And then secondly, you could lose. In fact, it's very likely you'll lose. What will happen to your bank account if you lose? You'll just lose the $3 you paid for the ticket. What's the probability of that? It's just 1 minus, right? I would literally just type in 1 minus 1 divided by 240, hit enter. It'll take care of the numbers for you. Right? It's just 1 minus the last thing, huh? It's probably the easiest thing, just 1 minus. The opposite is always 1 minus. Like that, hit the buttons. X bar, the average expected value is going to be something negative, like negative $2 and something. $2.69. On average, we're losing $2.69 when we buy that ticket. It's a little bit funny on this kind of problem because there's no way to lose $2.69. You either win big or you lose $3. But on average, people will lose $2.69. Is that making sense? We good there?